Welcome to Study Loop.
Okay, so this question asks, what is the minimum volume of the flask in order that there's no liquid water present in the flask? So basically, it wants you to calculate the volume of the vapor. So in terms of gas, in terms of vapor, the first thing we need to think is definitely the ideal gas law. So for ideal gas law, we know PV equals to the nRT. So think about in the flask, we want the volume, and if the pressure is given, the temperature is given, and the moles is given, then we can get the volume. And that's exactly what this question about, right? It gives the pressure, gives the mass. From the mass, you can calculate the moles of the water, and it gives the temperature. So now let's just write down those values. So for the pressure, it gives us, which is 28.36 millimeter mercury. So we need to convert that into the Pascal, which is 36 times the I think 1 milliliter mercury equals to 133.322 Pascal. And this actually equals to, let's use the calculator to do the calculation, 133.322. Okay, this actually equals to 3,781.01 Pascal. And how about the moles? The moles equals to the mass over mole mass. So the question gives us the mass is actually 0.055 grams and over 18 grams per mole. So that is around 0.0306 more. And the temperature, what is the temperature? It's 28 degrees C. And let's convert that into the Kelvin, which is actually around 301.3 Kelvin. Now what we need to do is just plug in the PV equals to nRT. And we do a rearrangement that V equals to nRT over P. So now let's plug in the number. The R is 8.314 and the P is 3781.01. So now let's use the calculator again. 0.0306 times 301.3 times 8.314 over 3781.01. And this actually equals to around 0.0203 meter cubes. And this actually equals to around 20 liters. So you actually need around 20 liters of the flask. I don't think that exists. So this is the answer.